Hi there, and welcome to the Chaotic Classroom. This video was created as question paper practice for grade 9 natural science learners who are struggling a little bit with electricity questions. Now, before you just watch the video, I would like for you to stop. The question paper has been linked in the comments. I suggest you first work through the question paper under exam conditions, and then you come back and you mark the question paper with us. Now I'm going to skip right ahead to question number 2. So let's read the first sentence. An experiment was conducted as part of an investigation to establish the influence of the thickness of a conductor on the resistance of the conductor. Now this is such an important question. Why? Because they're basically giving you the aim. And once they've given you the aim, they have also supplied you with the dependent and the independent variable. And the only thing that you have to do is figure out which one is which. So let's have a look. Now in this particular aim, they have given you the 2. So let's have a look at the variables. They've given you thickness of a conductor and the resistance of the conductor. So that's our 2 variables. And in this case, they wrote it as cause and effect. So the thickness of the conductor will be the cause and the resistance of the conductor will be the effect. Or the cause will be our independent variable and the effect will be our dependent variable. And it's very nice because now they're going to link this to the rest of our procedure. So let's have a look at the rest of the procedure. 3 cells, a switch and an ammeter and a metal conductor labeled A were connected in series. A voltmeter was connected in parallel across the conductor, and the switch was closed, and the readings on the ammeter and the voltmeter were noted. Ohm's law was used to calculate the resistance of the conductor. The experiment was then repeated with 2 more metal conductors with different thicknesses, B and C respectively. And then what is very nice with this table is they're giving you all of the information, what they used, how long the conductor was, etc. But here's what's important. If you look at this table, you'll see that everything is exactly the same except for the thickness of the conductor. We changed the thickness of the conductor, and that now ties back to our aim, which is the cause. So that will be our independent variable. And the things that they are keeping the same over here, the type of material, the length of the conductor, those types of things, that will be our controlled variables. And they are going to be the things that we need to do to ensure validity. Because remember, controlled means validity. Now, after the table, they have given us a graph as well. So let's have a look at the graph. They say the following graph was drawn from the results obtained. It represents the relationship between the thickness of the conductor and their resistances. So again, what are they doing? They're giving us the 2 variables, thickness of the conductor and the resistance of the conductor. So let's quickly remind ourselves, where does which go on a graph? So thickness of the conductor, that is always the independent variable here, and the independent variable goes on the x-axis. In this case, the resistance is the dependent variable, so the dependent variable will go on the y-axis. Right, now that we're done with our questions, let's have a look at our first. Right, now that we're done with our information, let's have a look at our first question. Question 2.1.1. Use the information given in the experimental procedure and draw a circuit diagram of the setup. Indicate the direction of the conventional current in your diagram. Now hopefully if you are grade 9, you will already know how to draw a circuit diagram, but I'm going to quickly run you through this as well. You're going to start by drawing the power source. In this case, remember again, when you're drawing a cell, it's one long line and one short line. If you have been told to draw a battery of 3 cells, like you were in this case, it has to be long line, short line, long line, short line. I always start with the power source. Then we draw the ammeter, which is a circle with an A. We draw our switch. In this case, the switch was closed, so that will just be 2 dots. And then we use a ruler to connect all of these elements together. Now remember, this entire thing should be done in pencil. The one element that we just need to remember to add is our voltmeter, and remember, voltmeters are always connected in parallel. So you're not going to put that in series like you did with the ammeter, you're going to connect that in parallel. Now once we get to this, it is very important to understand that there's going to be marks allocated in the question paper. So have a look, there are 5 marks. We've got given a mark for our cells, we give a mark for our voltmeter and everything. But it's important to remember to still answer the question. Okay, so you have to go back to the question, have a look, and remember that last little step was talking about conventional current. Now remember, the long line is always positive in a cell, the short line is a negative. So in conventional current always runs from positive to negative. You don't have to indicate it with 100 arrows. 1 arrow showing the direction of the current would be more than sufficient to give you the marks. Now the next 2 questions are going to be quite easy because we've already done the thinking for these. So question 2.1.2, write down the independent variable in this experiment. What is the independent variable? Well, it is the thickness of the conductor, because that's the thing that we decided to change. Then question 2.1.3 is the name 2 variables that need to be controlled during this investigation. And that is going to be our list of things that we got from that table. And that's going to be the type of material, which in this case was nichrome. So if you just say that all of the conductors were made from nichrome, that is fine. The length of the conductor, you can even mention how long they all were, or the time taken to note the readings, or you could have said that it was the 2 seconds. There you could be a little bit more specific there, which is more than fine. But those are the 3 things that was kept the same during this investigation. So if they talk about 2 variables that need to be controlled, they're looking for the things that were kept the same during the entire investigation. Then question 2.1.4, use the graph and write down the conclusion that can be made related to the relationship between the resistance and the thickness of the conductor. Now remember, the moment they use the word relationship, they're looking for when the, and then they'll usually talk about the independent variable, which in this case is the thickness of the conductor, changes, and you have to say, does it increase or decrease or stay the same? And what happens to the other one? Then what happens to the resistance? Will that increase, decrease, or stay the same? So let's have a look at how you would write that. First of all, you're going to start with your thickness of the conductor. You're going to say, as the thickness of the conductor increases, because if you look at your graph, it went from 0,5 to 1 to 1,5, so it increased. Okay, then we look at our resistance, which is our dependent variable, the resistance, and now you have to see what happens to the resistance. It was 3, then it became 2, then it became 1, so the resistance decreases. So as the thickness of the resistor increases, the resistance decreases. And thickness of the resistor and the resistance is the 2 variables, but you're giving a relationship between the 2. So you're saying increase, decrease, or stay the same. But you have to read this from the graph. Remember, this is not a hypothesis, it's not a prediction. You actually have to get it from the data that was supplied to you. Then question 2.1.5. Use the equation R equals V over I, which is Ohm's law, to calculate the reading on the voltmeter for resistor A. The reading on the ammeter for this setup was 1,5 ampere. Now remember, when it comes to Ohm's law, we have certain things that we need to start off with. So I always write down what information I have at the beginning. So I write down, I've got the current, which is 1,5 ampere, that was given in the question. I've got the resistance, which was 3 ohm, that was given right at the beginning of the information. What I'm looking for is I'm looking for the potential difference, which is the reading on the voltmeter. Now we're going to start our calculations, and the first part we're going to start with is we're going to write down our formula. But the thing is, the formula they gave us is actually the formula to work out resistance. We have to manipulate it a little bit so that it actually gives us the potential difference. So we're going to take the R equals V over I, and we're going to manipulate this formula so that we can get V equals I times R. How are we going to do that? Well, we're going to use our little triangle. The triangle looks a little bit like this. So R sits here, and then V is at the top, and then I is over there. So if we use our formula here, you'll see that if we have R, we take V over I. But if we want V, we're going to take R and multiply it by I. So once we've changed our formula, all we have to do is substitute into the formula. So we have those values already, and then we just have to calculate our answer. And we have to remember, it's not just a mark for substitution and answer, it's also a mark for the unit. So please remember to add the unit. Then question 2.1.6. A second conductor with thickness X is now connected in parallel with conductor C. This additional conductor in parallel will have one or two effects, C1 or C2, on your results. So basically they are giving you a graph with two options. So we have option 1 and we have option 2. Now when you look at this, you would realize that we are actually adding an additional resistor in parallel. That is important because that means that our answer should be option 2. So the answer here should be C2. When you add more resistors in series, you are increasing the resistance. But this particular resistor was added in parallel. Now, if you add more resistors in parallel, you are going to actually decrease the resistance. So you're going to get 1 mark for saying more resistors in parallel, and you're going to get your second mark for saying that this will lead to a decrease in the total resistance of the section. Now, there is an alternate option which you'll see on the memo, which I have also linked in the description, and that is that if there's an increase in thickness of a conductor, and remember you've now put two conductors actually together, if you increase the thickness of the conductor, you are actually going to decrease the resistance as well. I'm not as fond of this description as the other one, because the other one has been proven by scientific study and so on, but we will add that as an alternate as well. Question 2.2. Let's have a look at it. The circuit diagram below shows a battery, 3 resistors in series, R1, R2 and R3, and 2 ammeters, A1 and A2. There's a voltmeter connected across the battery, as well as across each of the 3 resistors. The reading on ammeter A1 is 2 ampere. The potential difference across R1 and R3 is 1 volt each. So the important thing that you're going to do first is you're going to determine, is this a series circuit or is it a parallel circuit? Because that will tell you which formulas you're going to be using here. It makes it a little bit more easy for yourself if you just add the readings from the paragraph onto the diagram itself. So that's what we're going to do here. So ammeter 1 is 2 ampere, we get that from the paragraph, and then we've got the voltmeter 1 and voltmeter 3, which is 1 volt each, and I've highlighted the pathway here that if you look at it, you'll see that all of the resistors are in series, and it was also mentioned in the paragraph, so that is important information. So let's have a look at question 2.2.1. Explain the difference between a cell and a battery. Now, this is one of those questions when people are proper true dinosaurs. I always call you you're a dinosaur if you didn't read the question properly or you are doing silly things to cost yourself mistakes in the paper. So how do we avoid being a dinosaur in this question? Well, it says, explain the difference between a cell and a battery. So to get full marks for this, you first have to explain what a cell is, and then you have to explain what a battery is. See, the mistake what a lot of people do is they only explain the one. They only explain a cell because that one was mentioned first, or they forget to mention the battery. So what is a cell? The cell is a power source, and it's going to be converting energy. And you have to mention what type of energy here. So it will be converting energy from chemical potential to electrical energy. And what is a battery? A battery is more than one cell connected in series. So that will get you your 2 marks. Then question 2.2.2. What will be the reading on ammeter 2? Give a reason for your answer. Now, it's important to remember here again that we already said that this is a series circuit. So if we think about a series circuit and we think about current, the formula that should be popping into your head is I total equals I1 equals I2 equals I3. Now, since ammeter 1 is 2 ampere and ammeter 2 is in series with ammeter 1, that means that ammeter 2 should also be 2 ampere. So that is the reading there. But you have to still give a reason for your answer, and you have to say that in the form of a sentence. So what are you going to say? You're going to talk about how the current is the same everywhere in a series circuit. That should give you your mark. Then if we look at question 2.2.3, the reading on the voltmeter across the battery is 4 volt. Calculate the reading on the voltmeter across resistor 2. So again, let's have a look. There's information in the sentence that's important. We want 4 volts, that's across the battery. And we want the reading of the voltmeter across resistor 2. So remember, even though it looks like an R there and you're thinking resistance, they're not actually looking for the resistance, they're looking for the reading on the voltmeter, which means they're looking for potential difference. Now, when we think potential difference in a series circuit, that means that we're going to be looking at the formula where we have to add the voltmeter readings across the whole circuit to get the total voltmeter reading. Then we need to substitute into that formula. We're going to do a little bit of manipulation and some math, and we should be getting to an answer of 2 volts. Where's our marks? Well, there should be a mark for formula, there should be a mark for substitution, and there'll be a mark for answer and unit. Now, I know the question says it's only for 3 marks, but you always show all of the steps, just for in case that there's a place where you might be actually squeezing an extra mark out somewhere if you made mistakes. So add all of the steps, show all your calculations, and show all your thinking. In question 2.2.4, what will happen to the reading on ammeter A1 in each of the following cases? Now again, remember, go and look specifically only at that one ammeter. And then it says, take note, only write increase, decrease, or stays the same. That's one of those places where we can make a dinosaur mistake again, where we're going to be not reading properly and then we do calculations or we write out full sentences, and that's going to cost our marks. So again here, slow down, read slowly, and make sure that you read carefully and that you understand the question before you even move on to the next step. First up, question 2.2.4.1. A third cell is in series is added to the battery. Now remember, the more cells we add in series, the more energy we're going to have and the faster the current will be. So we're looking for the word increase. So we can't here write faster or more or anything. We have to write down the word increase. Then question 2.2.4.2. One of the resistors is removed from the circuit. Now remember, when we take the resistors away, the current can flow faster, which means in this case the second answer would also be increase with a tick mark there. I hope you found this video useful and that you've actually used it the way it was intended. Thank you for visiting. Have a good test.